Hello, welcome back. Today I wanted to go over the process of looking at a sensitivity report produced after you solve a linear programming problem, an optimization problem, and go over all the details, all the information that the report provides and the kinds of questions that you can be asked and how to answer each of them. All right, so let's begin with an example. This is what I call in class the farmer's problem. So here's a story. The farmer has 45 acres of land where they can plant wheat or corn. So the two variables would be W and C, how many acres to plant with each crop. Now, acres planted with wheat generate a profit of $200, and acres planted with corn generate $300 in profit. To plant, I consume resources, right? So there is the 45 acres of land. So all that I plant, wheat plus corn, at the most what I have of land. And the wheat and corn consume the labor and the fertilizer resources at these rates here shown in the table. So I have 100 units of labor available. So to plant wheat, I consume 3. To plant corn, I consume 2. So this is constraint here saying don't consume more labor than what you have, and similarly you have a don't consume more fertilizer than what you have constraint. All right, so let's say we put this model in Excel the usual way and we go ahead and solve it. And when we solve it, we generate a sensitivity report, which are these two tables down here. And I want to go over these with you now and explain exactly what these numbers are saying and the ways in which they can be used. All right, so the sensitivity report will have two tables, a table for your variables, the top one, and a table for your constraints. The top table will have as many rows as you have variables, in this case 2. All right, so here the cell will simply indicate in Excel what cell reference represented the wheat variable B4 and C4. These names here are things that Excel tries to deduce given the way you labeled your sheet. So let's take a look at the next columns. The final value column is simply what the answer is. So once you solve and optimize, what is the best thing to do? It is to plant 20 acres of each of the crops. The reduced cost column we're going to ignore for now because later on I'm going to show you how to calculate the reduced cost, what the reduced cost means and so forth, so don't worry about this right now. The next column, the objective coefficient, is simply, well, the word coefficient is simply a fancy name for a number that multiplies a variable. So the objective coefficient are the numbers that multiply each of your variables in the objective formula. So if you go back to the math, to the model, 200 times wheat, that's why this is 200. 300 times corn, that's why this is 300. So it's just a copy of what your math says. The interesting numbers in this report are these allowables, increase and decrease. What do they represent? So they indicate the following. Given that you have these constraints here and these objective coefficients, the best thing to do as of now is to plant 20 acres with each crop. What if I were to change these objective coefficients, okay, one at a time? So for example, if the profit for wheat were to go up or down by a little bit, would it still be the best idea to plant 20 of each? And the answer to that question is yes, you should still plant 20 of each crop as long as the profit for wheat increases by no more than 250 or decreases by no more than 50. In other words, this number that is currently 200 could range between 200 minus 50, that's 150, and 200 plus 250, that's 450. So as long as the profit of wheat is between $150 per acre and $450 per acre, assuming all other numbers in the problem stay the same, the best course of action would still be to plant 20 of each crop. So this is basically, these allowables here are basically telling you how robust is the current solution with respect to changes in the objective coefficients. Great. So let's say you're looking at a certain change to your model that does not change the optimal solution. For example, what if the profit for corn goes down by $100? Well, it's currently 300. The allowable decrease is over 166. So if you're telling me this is decreasing by 100, meaning it's becoming 200, it's within the allowable, therefore the current solution stays the same. At this point, it's important to differentiate what is the solution and the value of the solution. The solution is your course of action. What are you doing? I am planting 20 of each crop. The current value of the solution with these current profits is what? Well, these 20 acres generate $200 each, so that's 20 times 200, 4,000. These 20 acres generate $300 each, 20 times 300, that's 6,000. So currently, this solution is worth $10,000 in profit. If I were to lower, right, the profit of corn to 200, because the decrease is within the allowable, I can tell you the optimal solution will remain 20 of each crop. But the value of the solution is not going to be 10,000 anymore, because 20 acres that used to make $300 each now only make $200 each. So despite not changing what I do, the value of what I do has gone down by how much? Well, I lost $100 20 times, right? So that means $2,000 less overall, 100 times 20. So my new solution would still be 20 wheat and 20 corn, but my profit would be $8,000 if I lowered the profit for corn from 300 to 200. All right. Okay, so if I were to ask you what happens if you increase or decrease one of these coefficient numbers beyond these allowables, the answer is the solution would not stay the same, and I can't tell from just looking at the table what the new solution would be. I would have to resolve the model after updating or changing the data. All right, great. So these are the main uses for the top table. Now let's look at the bottom table. The bottom table tells you things about your constraints, and you're going to use it if the question that's being asked is saying that a number in the constraints is going to change. More specifically, the changes that we have looked at in class were changes to what I'm calling the right-hand side numbers of the constraints, which are the numbers to the right of the symbols here. So let's begin looking at what this bottom table says. Well, the name, again, as before, is just the labels that Excel tries to infer from how you labeled your sheet. The numbers here on the right-hand side in your math are simply copied under the column called constraint right-hand side, so they are going to match the same. The final value down here in the constraint table simply refers to, well, what did the left part of your constraints turn out to be after you solve the problem? Meaning, once I know that W and C equal 20 each, I can calculate the values on the left-hand side of the symbols, and those turn out to be whatever the final value column says, right? So for example, I had 100 workers, I did use all 100 of them. I had 100 tons of fertilizer, I did use all 120 of them. And I had 45 acres of land, and I actually accidentally erased something here. And I did use 45. Let me see if I fix this before I ran into too much trouble. And I did not use all 45, right? The answer was I used only what? Let me had accidentally moved. Let me see if I can move this over here. Erase, not erase that 45. Okay, great. So let me, this was like some problem from the other, where I copied this from. So let me put that back there. This number would have been a copy of, so this is a 45 right here, okay? Great, so I had 45 acres of land to use, but I only use 40. That's what this 40 here is telling me. Okay? This 40 down here is saying you use 40 acres of land because it's 20 plus 20, but you had 45 to use. Great. Now, the interesting and more useful numbers in the bottom table are the shadow prices and these allowables. So let's take a look at what they mean. When your constraint is like one of these, where they're representing a limited resource, in this case labor, fertilizer, or land, the shadow price has an economic interpretation that is the following. It is the marginal value of having an extra unit of that resource. So for example, if I had one more unit of labor, I don't need to resolve this model to tell you the following. My profit would go up by $25. Oh, what if I had 2 more units of labor? Would it go up by 2 times 25? Yes. What if I had 10 more units of labor? It would go up by 10 times 25, 250. Can I do this forever? No. This is where the allowable increase and decrease come into play. They mean the following. This shadow price here, in this case of labor 25, can be used to assess the impact of changes to the right-hand side of the labor constraint, as long as the changes you are proposing are an increase of no more than 20 or a decrease of no more than 40 to the number here that is currently 100. Okay, so meaning as long as you want to raise this number 100 by no more than 20, so it can go up to 120, or lower it by no more than 40, every unit that you change this number 100 by will have an impact of $25 on your profit. So a couple of things to keep in mind. The unit of the shadow price will match whatever is the unit of your objective. So currently this objective here is in dollars. So the shadow price numbers are also in dollars. If this objective were people or gallons of water or something else, the shadow price would be in that same unit. Okay? The other thing to keep in mind is the impact to the objective value depends on whether or not the change you're making to the right-hand side number is an increase or a decrease in terms of the sign, right? So one way to think about this is the following. You can say the change to the objective value is going to be the change to the right-hand side number times the shadow price and what I mean by the change is if you were raising the right-hand side number, this change is a positive change. So you put a positive number inside this parenthesis here. If you are lowering the right-hand side number, this change is a negative. So inside this parenthesis here, you put a negative number, the amount of change. And the shadow price could have a negative value, in which case the table will show a minus in front of it. So you're going to use inside the shadow price parenthesis whatever number is showing in the table, be it positive or negative. So there's some misconception that a lot of people have is that, oh, they look at a negative shadow price means, oh, this is a problem. No. You have to consider always three things in order to tell, is a given change that I am proposing beneficial or not to my problem? And the three things to consider are the following. First of all, am I maximizing or minimizing? Secondly, is the change I'm proposing a positive change? I'm going to refer to the change as a delta. Am I increasing the right-hand side, or am I decreasing, subtracting a delta number from it? Okay. And is the shadow price positive or negative? Right? Let's look at these possibilities. If I am maximizing, I like changes that drive my objective value up, right? Well, when is that going to happen? Well, if the change I am making to a right-hand side number is positive, and the shadow price of that constraint is also positive, the change to the objective is going to be the product of a positive change with a positive shadow price, which results in a positive number. And because I am maximizing, I like it because it's driving my objective up. Likewise, if I am making a change to a constraint by decreasing its right-hand side, so the change is a negative amount, and it turns out that the shadow price of that constraint is also negative, the result to the objective is a negative times a negative, right? By this formula in red, which is a positive, and I also like it because I am maximizing. If I was minimizing, I will like when my change to my objective is a negative, that is, I'm driving the objective down. Let's say this is a minimized cost problem. So a negative shadow price paired with a positive change to the right-hand side is a good idea, because a negative times a positive will result in a negative that drives my objective down. Or likewise, if I have a constraint with a positive shadow price and I'm changing its right-hand side down, meaning the change is negative, negative times positive will result in a negative impact to the objective value. And if I were minimizing, I would like that. Okay? So always consider the three things. Are you minimizing or maximizing? Is the change you are proposing to the right-hand side positive or negative? And is the shadow price positive or negative? So great, let's look here. So in this case, if I got more workers, positive change times positive shadow price, my profit will go up. I like it. If I were to lose workers, if I lost 2 workers, I go from 100 to 98, then it's a negative 2, right? I'm changing this number in the downward direction. A negative change of 2 minus 2 times positive 25 is a minus 50. So if I only had 98 workers, I would be making not $10,000 anymore. I would be making $9,950. Now, an important thing that is also a source of confusion, in the variable table, if the change I am proposing to objective coefficients is within the allowable amounts, the conclusion is the current solution stays the same. A lot of times students get confused and think, oh, if the change I'm proposing in the bottom to the right-hand side, right, is within the allowables of the bottom table, solution will stay the same. No, these two sets of allowables have nothing to do with each other, right? The only change that keeps the solution the same is a change to objective coefficients up here within these allowables. If you're changing things in the bottom, in the constraints, right, within the allowables, that only means that the shadow price remains valid. It doesn't necessarily mean that your solution will stay the same. And in fact, in the example I just gave you, if I had 2 fewer workers, there's no way I can still plant 2020. The solution will have to change because the 2020 solution needs 100 workers. Okay, so don't fall into that trap. Great. So we looked at shadow prices here, and we understand they can be used only when the change you are proposing to the right-hand side number is within the allowables. A couple more clarifications. In the special case, notice that sometimes the shadow price could be 0. What does that mean? In this particular case of the land here, I'm not using all the land that I have. So the meaning of that 0 is if you had more land, assuming that this is the business you're involved in, it wouldn't help, because the resources that are constraining your actions right now are actually the other two, the labor and the fertilizer. So having more land is worth no money to you at the moment. That's why this increase here is this 1e plus 30, which is basically plus infinity. Even if you gave me a ton more land, that would bring no improvement to my profit. All right? Conversely, that's why the allowable decrease on the land is just 5, because notice if I lost up to 5 acres, I would still be fine because I'm only using 40. But if I lost beyond 5, the effect is not 0 anymore. The effect becomes a positive number. Great. So we looked at the first two key concepts, that is how to use the top table to determine when your solution stays the same after some changes to objective coefficients. And we used the bottom table to determine what is the effect on the value of your objective when you make changes to right-hand side numbers in your constraints. And we know how to use the allowable increase and decrease. There is a third concept I want to cover with you, and that's the idea of reduced cost. And to do that, let me just clear up this general area here, because it's a little messy right now. So reduced cost is a calculation, and again, don't get confused by the name reduced cost. It doesn't always mean a cost. It doesn't always mean that there's a reduction of some sort happening in your problem. This is just a name that has some historical significance and is related to the way these problems are solved. So what I want to illustrate is using an example. Typically, this reduced cost calculation will be something that you use when you are considering the introduction of a new decision in your problem that wasn't there before, and you want to figure out, is this a good idea? Should I pursue this? So let me give you a specific example. This farmer is currently limited to planting wheat and corn. What if they said, you know what, I really like alfalfa, and I'm maybe debating, adding that as my third crop. So they could do some research on alfalfa and figure out that, alfalfa uses these two resources the following way. So it's like there's a third column here in this table, alfalfa, and it needs two workers and 2 tons of fertilizer. And let's say the profit for alfalfa per acre is 170. Right? Let's see, I had this data. The first thing to do is, is alfalfa a good idea? Well, let's look at this in the following way. First step, always go back to your math and change it to incorporate the new possibility, the new variable. Right? So if alfalfa was potentially part of my problem, how would this math change? Well, in the objective, I would add plus 170 alfalfa, right? Where the A variable means how many acres I plant with alfalfa. In the labor constraint, I would say, there's going to be a 2 alfalfa here. In the fertilizer constraint, also 2 alfalfa, because of these numbers up here, right? And in the land constraint, I would have plus alfalfa. Great. So now the question becomes this. If I were to plant 1 acre with alfalfa, what is the consequence of that? Well, think of this as it's a balance between there are some good things that come out of this and there are some bad things that come out of this. And alfalfa would be a good idea if the good outweighs the bad. For example, if I plant 1 acre with alfalfa, well, I get this $170. So this is a nice thing about doing alfalfa, right? So I'm going to get 170. However, if I give 1 acre to the alfalfa activity, wheat and corn will suffer in the sense that they will have less of the other resources to deal with, right? Because right now, wheat and corn can make $10,000 because I am giving them 100 workers just for them and 120 tons of fertilizer just for them and 45 acres just for them. If the alfalfa variable equals 1, it's equivalent to saying, well, I ate up 2 workers. So the wheat and corn now only have 98 workers for them. It's also equivalent to saying I consume 2 tons of fertilizer because I'm doing 1 alfalfa. So wheat and corn now only have 118 tons of fertilizer for themselves. And because I consumed 1 acre with my alfalfa, wheat and corn now only have 44 acres for themselves. Which means they can do less than what they were doing before. And this is the bad side of alfalfa. Well, when right-hand sides of constraints change, I know how to assess the impact of that. I can use the shadow prices. So for example, if I lose 2 workers, every worker I lose is $25. So from this good side of alfalfa, 170, I'm going to subtract, right? 2 workers, each of them worth $25. If I lose 2 tons of fertilizer, each of them is worth 62.5. So another loss here is 2 times 62.5. And if I lose 1, and again, let me put back that 45 number, which got erased by mistake. I apologize. This was a 45, right? If I lose 1 acre of land, right? Because I planted the one with alfalfa, the loss here is 1 acre. But the sensitivity report says, no worries, it's 0. Right, so what I have here is the following. The 170 is the good side of alfalfa. The stuff in this parenthesis is the bad side of alfalfa. What is bigger? Well, if you calculate what's in the parentheses, it turns out to be 175. So the difference, the result is minus 5, right? Because I had 170 minus 175. So what does this mean? This number is the reduced cost of alfalfa, which essentially means what would happen to the value of your objective, which currently before alfalfa is 10,000. If you were to force yourself to plant 1 acre of alfalfa, and this is saying you would lose $5. Because my objective is a maximize, I don't like alfalfa right now. If I was minimizing and the variable I am debating, introducing, has a negative reduced cost, it means using that variable would drive your objective value down. And if I am minimizing, I like that variable. So again, don't fall into the trap of thinking negative is evil and positive is good. It always depends on, are you minimizing or maximizing? And is the impact to your objective an increase or a decrease, right? So if you're maximizing, you like increases. If you're minimizing, you like decreases. So if tomorrow, suddenly I open the paper in the commodities section and alfalfa now has a profit of 180, then this would become a positive 5 and alfalfa would be a good idea. Notice this is not telling me, let's say alfalfa becomes good because I went to 180. This is not telling me how much alfalfa I'm going to plant. It's just telling me planting alfalfa would help to know exactly how many acres of it to plant. You would have to solve the model again. All right? So this is the idea of the reduced cost. It's a, if we will, a battle between what is the good side of adding that variable and the bad side of adding that variable. Another comment I wanted to make, just to finish this off, is we mentioned that the changes we are assessing are one change at a time. What if you are thinking about multiple changes at a time, right? And there's a rule that you can use to determine if the multiple changes you are considering, if I can calculate or assess their impact with the sensitivity table that I am given or not. And this is called the 100% rule, and it works like this. This only works if you're considering multiple changes to objective coefficients or multiple changes to constraint right-hand sides, but not like a combo of them, like one change up here and one change down here. So the 100% rule works like this. Let me give you an example. For example, let's say I'm considering a decrease in the profit of wheat of $20. So profit of wheat would change down, right, to become 180. And let's say profit of corn would change up, okay, to become 350. So increasing this by 50 and decreasing the wheat profit by 20. Can I still claim that the solution will stay the same, for example, right? Well, here's what you do. Look at this amount of change in wheat is a decrease of 20. Look at the allowable decrease. It's 50. So in percentage terms, out of the 50 that I could decrease, I decreased 20. So I consumed 40% of what I could have decreased. I decreased by 20 and I could have decreased by 50, okay? 20 over 50. And in the direction of an increase for corn, I could have increased by 100 for the solution to stay the same. And I increased by 50, so I consumed 50 out of 100. Okay? Notice that I'm looking in the direction of the increase. Because it was a minus, my denominator is the maximum decrease, and because for corn it was an increase, my denominator is the maximum increase. So if I add these two proportions, I consumed 40% of the first possible change, or with the first possible change, and I consumed 50% here. If I add these up, I get a 90%. Because this is less than 100%, the impact of these two combined changes is equivalent to the individual impacts of each change. So because they are both within the limits, solution will stay the same. And I can also calculate the updated profit, which is to be, well, I'm going to lose, right? For this first case here, I'm going to lose $20 20 times, right? That's 400. And here I'm going to gain $50 20 times. That's plus 1,000. So the net is plus 600, right? Plus 1,000 minus 400. So the new profit would be 10,600 with the same solution of 2020. You could have done this in the bottom, right? For example, if you say that I'm gonna get 10 more workers, right? So I'm adding 10 workers here. And I'm going to lose 10 tons of fertilizer. Okay. Well, let's see. 10 more workers, the allowable increase was 20. So 10 over 20 is 50%. 10 fewer tons of fertilizer, the allowable decrease was 53. I don't need to calculate to know that 10 over 53 and a third is less than 50%. And because the previous one was 50%, this whole thing is less than 100%. Therefore, the impact of the combo of these two red changes down here equals the sum of the individual impacts of each change, meaning your profit will go up by this 10 times 25, and it will go down by this 10 times 62.5, right? So you're going to have a plus 250 minus 625. So the net is a loss, okay? Here. All right, so this is how you can assess the effect of combined changes as long as they obey this 100% rule as I explained here. You can calculate the individual changes. And this is it for now for the sensitivity report analysis. I hope this is useful for you guys, and I'll see you in the next video. Bye-bye.